Homework packet 4C, lesson 412. Part A, we have rectangle, and we have another rectangle inside, and we have diagonals, and the top right corner of both vertex is on the diagonal from left bottom to right up. Now, how do we know these are scaled copies to each other? Well, if we erase the bottom part of it, and if you just focus on the top part of the split it, so if you split that rectangle into two, cutting along diagonal, we'll have a triangle on top and the bottom. If we focus on either one of them, then the line, then we can use the side splitter theorem, actually parallel side splitter theorem, to prove that the part to whole are proportional. Therefore, they are scaled copies. So I want you to write it out in your own words. In the triangle shown here, segment DE, so we have triangle ABC and D on AB and E on AC, and D is parallel to BC. Explain why triangle ABC is a scaled copy of triangle ADE. So you can use parallel splitter theorem, lesson 4.1 instead of 4.2. You can apply that idea to prove that these are scaled copy. In order for two figures to be scaled copies, they have to be to each other. The side lengths has to be split proportionally, and parallel side splitter theorem explains that part. So explain that in your own words. Problem 6. You draw the size of the outer polygon parallel to the side of the inner polygon as shown at the right. Explain why the polygons are scaled copies. So this is pretty much the same problem for problem number 5. If we just, instead of just focusing on entire figure, if you could just look at one triangle, for example this one, then that problem will be pretty much the same as number 5. And if you apply that for 3 other triangles, that's going to be a scaled copy. So we can start from problem number 5 and then repeat 4 times, or just as repeat apply to 3 other triangles. Then that's going to prove, that's going to explain why the polygons are scaled. Problem number 7. Suppose ABC, triangle ABC, is a scaled copy of BED, or BED. Okay? And which of the following lists the congruent corresponding angles of these triangles? Is A congruent to DBE, which is here? Are they congruent? No. So A is not the answer. So that's how you solve this problem. Problem number 8, 9, 10 are take your father problems. So good luck.